Okay, so now finally a graph here, and so you can. This is x squared minus xy plus y squared equals 7. Used to be things like that would be pretty difficult to graph, but now you could put that in Desmos right now and it'd graph this thing perfectly for you. I mean, you would see this exactly. But anyway, so it wants to know the equation of the tangent line. But the thing is now, the tricky thing is you got to have an x and a y. So negative 1, 2. If I just said negative 1, though those may be the same, who knows? We're finding the equation of the tangent line right there, and also as for the normal. All right, so we'll do both of those. And once we have the slope, we already know the x and the y. They told us. If they did not tell us, you'd have to substitute in and solve for one of the variables, that kind of thing. So, but they did tell us both of them, so that was nice of them. So here we go. Derivative, 2x. Oh my gosh, you got to be careful. This is subtraction of a product rule. So notice the parentheses here. So first times derivative of the second. The x times y has been quite popular in the last couple of questions. All right, and so then plus the second times derivative of the first, so that's just going to be a y. Now, if you did not put the parentheses, of course, you could just think of the first as negative x, and all this would work out. But just to be on the safe side, I just say subtraction and then do a product rule so I don't mess up. And then 2y dy dx, and then your right-hand side is 0. Okay. All right. So that's good. And then let's gather. All right. So on the left-hand side, this is going to be a negative x dy dx. Here, I'll just distribute the negative. We got room. So minus x dy dx. This is what you would have gotten if you just considered the first term there, negative x, and the second one y. It would have been the same thing. But like I said, it makes me a little nervous. So I want to make sure I don't mess up by forgetting to distribute a negative 1. Okay, so again, a step you probably could have skipped, but then let's gather I'm going to gather and go ahead and factor. So on the left-hand side, I'll have dy dx equals, times negative x plus 2y. And then the other two terms do not have a dy dx, so they're going to the other side, and that'll be a y minus 2x, something like that. All right. So now my slope at all values of x and y on this particular graph, it's not a function, will equal this crazy looking fraction. All right. And so that's my slope of my tangent lines. All right. It'll be y minus 2x and divided by, if you want, 2y minus x. However you want to put that. Okay. So then this evaluated when x is negative 1 and y is 2, because this would be the slope that I need, it's going to equal. All right, so my y is 2. So I have 2 minus a negative 2. So minus a negative 2. And on the bottom, again, I'm substituting 2 in for y. So that'll be 4. And then x is negative 1, so that'll be plus 1. So my slope at this moment is going to be 4/5. And man, that's all I need because I've got everything else. I have the x and the y, and now I have the slope. So that tangent line, let's see if I can even come close to drawing it. That tangent line right there, all right, has a slope of 4/5. So here's the answer then. All right, over here to the side. Here, I'll change colors. So I have y minus y1, so y minus 2 equals the 4/5 we just found. That was the calculus we did. Everything else is just substitution. And then x minus my x will be x plus 1. And now for the normal line, which will look a little something like this. Oh my gosh. Pretend like that's good. Negative reciprocal slope, I can just answer it. So I've got still y minus 2, still still intersecting when the y is 2. But now my slope is the negative reciprocal. So it's negative 5/4. and then x plus 1. So purple line, purple line, that equation there. Red line, that equation right there. And we are done.